In 244, just this morning, how many of you guys think TV commercials are too loud compared to the shows they're at? Right, so we decided to test it in 244 today. We collected some data. I've had it for years, actually, and we decided to test the claim TV commercials are too loud. And what's interesting is 2 years ago, the FCC was told by Congress to monitor that.
Yeah.
And if you look at online, they say things like, no more loud commercials. And I raise my hand, of course, because I'm me, and I go, what defines
loud?
Loud. Right? It's not well defined. That's the problem. It's all very subjective. And they put a question on their website that says, have you ever been blasted by a loud TV commercial in the past 6 months? Who the hell's going to say no? The only person on the FCC website is somebody that's pissed off already, looking for a place to complain, and they're going to stumble across that question, and they're going to hit yes. And predictably, it's 95-5. 95 yes, 5% no. What makes me wonder is who the hell's saying 5% no?
The ones who are deaf. The
ones who are deaf are the ones that are scanning the FCC website for fun? I mean, who the hell knows? So, yes, these are the kind of things I like talking about in class with you guys. I had some ideas right up the hill today, actually, for quizzes for you guys for next week. Jen asked me a very good question. How many more quizzes am I going to offer before the end of the term? I've been tracking you guys. I've been tracking you. Sorry, but to be big brothery. Just looking at how many quizzes you guys have turned in and how many you still have to turn in, and hopefully you see that in the progress reports. It always tells you. I can guarantee at least one more in class, and there's two this week, right?
Yep.
Yes.
I'm thinking 3 next week. Only 3, not because you have to do them all, but in case you need to catch up, you'll have 3, and then probably 2 the following week. So I mean, there's a buttload left. I mean, I think it's at least 6 left, 5 or 6 left. I mean, if you think about it, if I post 5. That's half what you need for the whole term in the last 2 weeks of the class, or the last 2 weeks of the class. I mean, it's definitely upped. So I won't leave you guys hanging as far as that goes. But I'm not just going to stop posting quizzes. Don't get nervous if you look at the schedule page in week 9 and week 10 and there's nothing linked yet, quiz-wise. It's only because I have to see where we are this week to know what to post next week. Does that make sense?
Yeah.
So I don't like to put something up that I don't have to pull down or remove the due date on. I'd rather have it there ready to go. So this week, it's Gambler's Ruin, which is one of my absolute favorite quizzes. That's a super fun one to do. And the other one that I can't remember right now. Gambler's Ruin and... Oh, the Sarah Palin Binomial one. One of my favorite articles I ever read. Sarah Palin, Political Catalyst. I'm like, let's test it. I mean, all politics aside, let's just look at the data and see if it says anything. And that's... Today will help with that quiz, FYI. What we'll do today will help you with that Sarah Palin quiz. It's like an extension of the chickens. If you think of it that way. It is. And what I want... Thank you for saying, is it? I love that, Sandra. Thank you. Because if you think about it, the reason we spent last Thursday, and I know a bunch of you guys weren't able to get here last Thursday, and I appreciate those of you that did, and hopefully those of you that didn't were able to watch the videos and check the class out. The reason we spent that whole block of time building my chicken flock is everything binomial will now be chickens. Everything can be reduced to flipping a coin and identifying the likelihood of heads and tails, which is essentially what buying a chicken is out of the store. Max grabs a bird. It's a coin flip. It's either a boy or a girl, right?
Either a boy or girl.
All you got to ask yourself is, number 1, how many times did you flip the coin? And number 2, what's the other important question? What are the chances of heads and tails? Or just, what are the chances of heads? Because you can stop with that. Once you know what heads are, you know what tails are. So, but what are the chances of heads and tails? So how many coins did you flip? And what are the weights of the heads and the tails? Everything. Sarah Palin's like that. Because Sarah Palin, in that, I think she did 64 races, is that correct? If you look at the quiz, I haven't looked at it since I posted it. I think she ended up trying her hand at 64 contests, and she either got them right or she got them wrong. So it's a chicken. Buying a chicken for her is putting her vote in on one of these contests. And chicken means she got it right, and rooster means she got it wrong.
Yeah.
Now the probability of her getting it right and wrong was actually, I actually had to calculate it for you in the quiz, because I realized as I was setting the quiz up, I wanted to make it 50-50. I'm like, well, that's not quite right. Because in some of those races, there were actually 3 people running. There was a Democrat, Republican, and then some third party that actually, believe it or not, in this day and age in America, there was a third party with a fighting chance, which I know hasn't happened since Ross Perot, which blows my mind. It hasn't happened since the 80s. 80s, I think it was 80s. Yes, yes. He got 20% of the popular vote.
Yeah.
Ross Perot got 20. Think about that. A third-party candidate got 1 out of every 5 people that voted. Was that Reagan? Who was pro was
Bush.
Big Bush Senior. And Dukakis? Perot, is that right? Yep. Not that Michael Dukakis had a snowball's chance at hell against HW, but still, the fact that, I mean, it's so funny to say HW versus W. It's so adorable. It was just Bush until Junior came along. But it's just amazing to me that third-party candidates, I love the fact that they do. I wish this country had more third, fourth, fifth, sixth-party candidates.
Yeah, I do too.
Oh my God. I mean, you look at an English ballot, yeah, right, there's like 12 parties on there. That's the way it should be. There shouldn't be two, anyway, sorry, soapbox, get off. Step down, get off. But I had to adjust her probability a smidge because there were enough of those third parties that it actually isn't 50-50. It ends up being, you have it printed there, son? Yeah, 48.7%. It's just below, it's about 1.3% below 50, which I thought was interesting. You know, it's not quite 50-50 if she's guessing, because there are enough third-party candidates to make it a little below 50-50. I thought that was fun. I figured, what the hell, we might as well do it. Let's use some tools we haven't used in a while. So, but everything's a chicken when it comes to binomiality. It is. I mean, honestly, here's the deal. Here's the formality. If you've seen the PowerPoint, you've already seen this slide. If you haven't, that's totally fine too. But here's the deal with binomial. Oh, here it is up here. Oh, you can't see this, sorry. This is how you identify a binomial, what's called a binomial random variable, which is what we were doing in class Thursday, which we will continue to do today. If it's binomial, it has to have these checks. First of all, you gotta have a fixed number of independent trials. I sent Max into the store, he bought 4 birds. He flipped 4 coins, right? If you think about it that way. He flipped 4 coins. Fixed. I didn't say, Max, go in and buy as many coins as you, or buy as many birds as you want. I didn't say that. I said, Max, go get 4. Daddy, can we have more? No, go get 4. I didn't say it quite like that. I wanted more, trust me. Now, see where it says arguably independent in there? What does that mean? Arguably independent. First of all, what does independent mean? From trial to trial, what does the independence mean? Anna, go. Go ahead, say it. You're doing the right motion.
Like if you don't put it back in.
Good, 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 good. So independence is like sampling with replacement each time, right? That's what independent means. Now, if you think about this, that's not what Max did. Max didn't pick it up and go, oh, I really like this one, and then put it back. I really like this one, and put it in the Happy Meal box, which came home, right? But why did we treat it as independent? Do you remember why? And this is the most challenging to identify, but also the most beautiful part, because it makes us able to do it this way. Why is it okay to assume they're independent, arguably?
Number of samples.
The size of the sample, versus, he only picked 4, right? If there were only 10 birds in the store and he picked 4, that wouldn't be independent, would it?
No.
Here's why, right? If there were 10 birds in the store, and there were 4, he went in to pick 4. Now, if there are 10 birds in the store, according to the guy that runs the store, 9 of them are girls and 1 of them's a boy. 90%, right? So what's the chance Max goes in and grabs a girl? First bird. That's a boy, 10%. So 90% girl, 10% boy. 90%. So 90% is the chance this one's a girl, right? He puts the Happy Meal box. What's the chance the next one's a girl?
80%.
Oh, you see what just happens? It's 8 out of 9 now, which now drops that to 88%, almost 89%, right? Which is still pretty close to 90. I'll put that in the box. He goes back in. What's the chance this one's a girl? 7/9, which is down to about 78%. You see what's happening? The probabilities are not staying close to 90%. And then by the time he goes in for the 4th one, it's 6 out of 8. It's 75%. Where'd 90% go? It's not 90% anymore. Eric, go.
Well, if we put the chicken in the box but we don't check what it is, isn't it still 1/10? Or
not of those that remain. So the trick is when you're doing it empirically like we are, you have to do it from the sample that remains. In other words, it's much more likely you're going to get one of those boys in a small population versus a large. I see what you're saying. You're kind of viewing that 10 as one subset of a large string of chickens, but that's why you shouldn't when you're trying to crunch the numbers to make the distribution. What you're saying is perfectly fine in the long run approach to it, but in a short run approach to it, like Max going into the store or you buying a lottery ticket, you have to account for the fact you're drawing from a small sample. Because it doesn't stay 0.9 from trial to trial. It varies too greatly. Right. Except when Max goes into the store and there's 1,000 birds. Now, mathematically, you still have to do the down 1 each time, right? It's 90. It's 900 out of 1,000. Now it's 899 out of 999. But what's that equal to? Arguably the same, 90%. I see what you're saying, Eric, but you're viewing it the way I just described the population being large.
Right.
And I love that.
Well, I was just thinking about the thing, like, if you have 3 cards and one of them is the card you want, but you just drop one of them face down on the floor, and then you pick between two. It's still a 1 out of 3 chance.
That's the Monty Hall question, right?
Don't know.
Right, but that's one sample, not successive samples.
Right. Okay.
That's the difference. The difference is, you're talking project 1, I'm talking project 2, if that's okay.
Sure.
Not to be a bastard. Yours would work if we stop the flock at 1 bird.
Right.
Mine's going to 4 birds.
Right. That makes
And
sense.
does that make sense?
Yeah.
Now, if you stop the bird, now here's the thing: if you stop the flock at 1 bird, you've drawn a small sample. Even with a population of 10, 1 from 10 is still pretty small.
Yeah.
But 4 from 10 is 40% of your population. That's a huge representation of your population. Is that fair?
Yeah.
Good enough? Look, what were you gonna say? Go, friend.
Presuming that the first one you picked wasn't the boy.
And that's the thing too, is you have to do the conditionality of that, assuming we got a girl and then a girl and then a girl. What if you got a boy? Well, when we're interested in actually just calculating the chance of getting all girls, I'm going to say, what's the chance I got a girl in the first one? I might still get a boy. Of course, I might still get a boy, but if I want to know the chance of getting all girls, I'm only going to focus on all girls. I love what you're saying. And we always have to wait. That's why we make the entire distribution, which we're going to spend some time today doing that with the TIs, is making more and more distributions. We have to do Gale's flock. 30 birds? 30 birds?
Yeah.
30 birds. We'll do that later. Because, Sandra. Sandra.
When we watched the video.
Oh, good!
I thought it was interesting because we had a friend of ours had given us their chickens, like you said, they quit laying. And they gave us the chickens, and then I'm looking at them and I'm like, that one's a male, that one's a male, that one's a male.
Nice chickens.
Yeah, the hens,
All your chickens have stirrups?
Right,
And they're
so
3 feet
it
tall.
was cute because we're like, well, the 5 hens out of the 13 that they gave us I was like, it's
Were
pretty hard
boys.
for those poor 5 hens
To
to
lay
lay
eggs.
enough eggs for 13 chickens.
Oh my god, that's hilarious.
Because the other 8 were...
Oh wait, so you got 8 roosters and 5 hens?
Yes, and he thought they were all hens that
Oh my-
were not laying very well.
Wait, we gotta talk about this. Did they start with 13 birds?
No.
Or do they have more and some
They
die?
had more, and then...
How big was the original flock, do you remember?
Did you remember what he said? I think 20,
I
wasn't
think
it?
it was like 20.
Yeah.
And there were 13 roosters?
Yeah.
No, 8 roosters.
8 roosters.
8 roosters. We're gonna calculate that one too. We're gonna calculate. But you see, the problem. Thank you for this. We're gonna calculate everybody's chicken flock today. The problem with this is, as soon as you start getting numbers like 20 and 30 and whoever else, ranchers that have hundreds of birds, those distributions that we were doing in class last time, they get really tedious to do, obviously, right? So you have to use technology to craft. If you don't want to spend all day making a tea table, you got to use this to help you out in making the tea table. Does that make sense?
Yeah.
Hopefully that makes sense. And we're gonna do that today. Very, very good. Thank you. So 20, 30, and whoever else we can get to. Mike Smith's got 7. We'll do his first. But anyway, what makes it chickens? Well, first of all, you have to have a fixed number. That's why I asked. Did he start with 13? Oh no, he started with 20. So I got a fixed number.
Right.
And we're going to assume that they bought even those 20 from a large population. Probably, if you're buying large numbers of birds, you're most likely getting them even not from a store, but from a distributor that distributes tens of thousands of them all over the country. Sure. Okay. This is the independent. We have to make sure we have 2 and only 2 outcomes. That's why it's called binomial.
Yeah.
If you have more than 2, it's fun. Trinomial, quadnomial, quintinomial, those are great. But they're a different approach. I'll come back to that because I got into a discussion once with a student who claimed there was actually a 3rd outcome. There should be a 3rd outcome. Similar to flipping a coin and having it land on its edge. They said some chicks, did I tell you guys this? Some chicks are born with both genders, male and female at the same time. And I was like, well, is there a 4th? Is there one that's born with no genders? And apparently not. Apparently, a chicken has to be born with at least 1 gender, but it can be born with 2. And I did some research, and as it turns out, it's a 1 in 10,000 chance. So roughly every 10,000th chick has both male and female genders.
Yeah.
So I reran the distribution with that in there, and as it turns out, it doesn't change a whole lot. Because it's such a rare occurrence, you're off by 0.04%. But the student was pissed. You need to account for this. It's like, okay, I will. And then I did, and I sent the results back. I haven't heard back from her since. That was 2 years ago. So, anyway, I always follow up. That's the thing. It might take me a while, but I always follow up. This is kind of tied back to both of these, but that's the parameters you have to have. We mentioned this already. There are 2 parameters for a binomial study. N, which is the fixed number of trials, and the probability of success on any given trial, which in our case was 0.9. So the idea is from that, you can get anything you need binomially. You can analyze the entire distribution, you can pull the average, you can pull the standard deviation, you can pull anything you need from those parameters, which is totally rad. That's what your program will do in your 83. It's what the binomial command in Excel does. Every statistical package anywhere has a command that runs the binomial. Excuse me, hiccups. That runs the binomial. So what I wanted to start with today was making sure you guys can run this too. We did it on Thursday, it was all by hand. Hopefully you guys that weren't able to make it on Thursday will kind of follow along and see what we were doing as far as constructing the distributions. Although it did take an hour and a half to work through 4 distributions, right? It takes a long time. And with the Sarah Palin one, for example, if you were to do the Sarah Palin by hand, I mean, you'd spend an hour and a half making the distribution. And you get done, you'd be like, cool, where's my 10 points? And I'd be like, well, you got 0 points because now you have to use it. Screw you, rule. Good, yes, exactly. That's why I gave you the program, was because this, once you understand how to fill it in, I don't need you to do that every time. I mean, you don't have to make a phone call by stringing up a can with string to your neighbor's house. You use a cell phone now because we've got technology to help us do things. So, this is what makes it a chicken. Fixed number of trials, fixed probabilities, independent, and you're golden. This, the arguably independent part, this does get squirrely. This does get squirrely. For example, Sarah Palin. I assumed that if she were truly guessing at those races, that she would be randomly generating her choices. That might not be true, right? That might not be true. Maybe one of her choices, the next choice was somehow dependent on that first choice, but if she's truly guessing, I can assume it's independent. Basically, she's got a coin in her, you know, she's flipping it, and that's how she's deciding, essentially, how to do it. I actually made 105 just do this last week. I said, okay, everybody, you remember doing this, Kendra, maybe. I said, everybody write down, imagine in your mind flipping a coin 10 times, and write down what you got. And they did. And then I said, put them on the board. I filled the board with 200 H's and T's. And then I gave them all a penny. I said, okay, now everybody flip a coin 10 times. And write those results on the board over here. Were there differences? Were there differences? Yes. What were the differences, do you think, between the ones they thought looked random and the ones that actually were random? What do you think would show up in the ones that actually were coin flips versus the ones that didn't?
Groupings of the same.
Big clumps. People were calling it weird on the front board. It didn't deviate very much from 5 heads and 5 tails. It would go like tails, heads, heads, tails, tails, heads, tails, heads, tails, heads, heads. And one person went something like heads, tails, heads, heads, tails, heads, 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 tails, heads, blah, blah, blah. And it was 3 and 7, like 3 tails and 7 heads. Somebody goes, you cheated! And I thought that was so cute. Because on the sideboard, like half of them had 3s and 7s. There was 1, 2, and 8. They're like, oh, what happened there? And they discovered what you guys already know, that random is clumps. If you're being true, you should get those clumps in there. So it's hard to believe, though, if somebody's trying to be random in their mind guessing, that they're going to guess with those clumps, right? It infuriates Max. Whenever we play, his new favorite game is guess what I flip. He takes a coin and flips it, and I have to guess heads or tails, and I always guess tails. And what he's figured out over the past like 3 weeks of doing this is that I get it right half the time, even though I never change my guess. And what I'm waiting for him to figure out is he always changes, and I'm waiting for him to figure out if he always changes, it's the same as never changing at all in the long run. It's the same thing, and this has applications to the lottery, right? How many of you guys know people that play the exact same number every single time they play, like a pick 3 number, right? Always play. My grandfather always played my 701 was my house address. He always played that in the lottery. Well, there's no difference if you always play the same number or if you change the number up every single time. It's still a 1 in 1,000 chance of picking the same 3 digits that come up in the machine. But that takes them getting used to, right? Because people have this idea that if I play the same number, that someday I'll be due, right? It's that I'll be due thing, right? I didn't see my number today. That means it's more likely to see a different number tomorrow than was here today. So say today's number is 166. Don't play 166 tomorrow because it already got used. It can't be used again. Sure it can. It's going to come up with 1 in 1,000 probability, right? Just like any other number, like 666 or 111 or 777. They're all 1 in 1,000 if you have to get all 3 numbers right.
Actually, you probably should choose the one that just won, because if you have to share the pot with the other people...
Who else is going to think like that besides a trained statistician? Good for you, Eric. Well done, sir. Somebody actually, it's funny you say that. I love how you said it and the justification for it. Somebody at 105 made an incorrect conclusion yesterday. They said, what did they say? Basically, what we ended up learning was randomness teaches you to look at a bunch of numbers to decide whether it was done randomly or not, but it doesn't give you the ability to predict what's going to happen next. And her vote was, well, I just saw a 2. I'm going to bet on 2 because randomness clumps. And I was like, ooh, slippery slope, right? Slippery slope. Because if there are three numbers, 1, 2, 3, which there were at the time, and you just saw a 2, there's a 1 in 3 chance you're going to see a 2 again, but there's a 2 in 3 chance you're not going to see a 2 again. So the clumps don't, the problem with the clumps is they happen, but you never know when or where. See, that's the trick. That's the trick. It reminds me of my prof, Vince Larisha. His favorite, I'll tell you the story if I did, stop me. He watched his favorite football team, college football team. He used to follow them religiously, and he'd do statistics for the team. His favorite team on the coin flip for 12 straight games flipped heads. Did I tell you the story? Or was it tails? One or the other. 12 straight. And he said, what's going to happen next? And we said 50-50, 50% heads, 50% tails. He's like, yep, but I'd go with heads. He saw 12 tails, I'd go with heads. Why would you say that? You have a PhD in statistics. Why would you say you'd bet because the pattern will be broken? You never know what's going to happen next, right? I'm sure somebody that just saw 8 tails coming in wasn't expecting the 9th one to be tails, or the 10th one, or the 11th one, or the 12th one.
Yeah.
Right? I mean, if you stop at a different point, it's like, holy shit, I just saw 8 flips in a row. Rectangles. It's not going to be tails. Shit, it was again. Won't happen again. Shit, it happened again. Bet the house. Shit, it didn't happen. Yeah, that's the thing, right? It doesn't give you a prediction of what's going to happen next. It allows you to look back and measure how unusual that was, but not to predict what's going to happen next. And that's the danger, right? That's how you get things like economic collapses and whatnot. Cool? All right. Any questions you guys have right now before we get going? Decent. So we now know how to crunch these things manually. Yay, yay us. Let's never do it again. Because the end of the discussion is not the actual distribution, it's what the distribution can tell you. That's why we do statistics. We don't do statistics to get a pretty table. We get statistics to get a pretty table and then do something with. Like, what can we conclude from this table? So, let's go a little bit further and talk about my buddy, Mike Smith, and his chicken flock. Okay? Mike heard me giving this talk years ago in the library. I've been using chickens for a few years now. And he came in and he said, he's like, I heard you talk about chickens, talk about roosters and getting eggs. He's like, I'm pissed. I'm like, why are you pissed, Mike? He's a great guy. Mike was fantastic. He doesn't work for us anymore, but he's a wonderful, wonderful dude. He's like, I bought 7 birds at the store, and I got a rooster. I was like, yeah, okay. He's like, well, I shouldn't have gotten a rooster. I'm like, oh, you wanted all girls. So you actually bought him sexed. He's like, yeah. So why'd I get a rooster? I'm like, well, it's probably pretty likely that you would have gotten a rooster. He's like, no, that's horse. Because he knew the 90%. He was told the 90% as well. So what I did was I sat down with him, with technology, and I developed the distribution for his flock. Now, if you remember from last time, I'm going to turn the mic off for a second, Mike. We were always using the same random variable last class. What was X standing for in every one of those distributions that we analyzed last class? Number of girls. Number of girls. That's what, thank you, Kevin. Number of girls. And it took on values from 0 up to what?
4.
Up to 4 in our case. But if I may, that's okay if you don't like this, I'm going to put an N there. Because really, it can go from 0 up to however many birds we buy, right? If we buy, Mike bought 7, we're going to let it go to 7. So 0, 1, 2, 3, 4, 5, 6, 7. Sandra, your neighbor had 20. 0 to 20. Gail, you had 30. 0 to 30. It's always going to start with 0. Because it's possible that even if you buy 30 birds, it's possible you get all roosters.
Yes.
Possible, just not probable. And we'll see just how improbable as we run through the program. That's where this really shines. That's where this thing really shines. And then, this column is the P of X column, yes? And this is where we have to find what's the chance of 0, what's the chance of 1, what's the chance of 2, all the way down to what's the chance of N. So what the program essentially does is just takes care of all those little tiny pieces we figured out last time together. It's a huge time saver. And then once we have it, we can do stuff with it. Hopefully we'll see that as we go through today too. Good enough?
Yep.
Let's do Mike's. So grab your TI. If you didn't get this linked up either last time or the time before, at break we'll share it with you for sure. But if you don't have it with you, just make sure you're sitting next to somebody that has it because it'll make life easy for you today. And I'm going to show you, I gave you a second program called Dist Draw that you might find interesting as well. You might not, but you might. Slide this in here. All right, so to get to this one, you actually have to press the program button, PRGM. It's directly below stat. I couldn't figure out how to actually get it to be in the stat menu. So, press the program button, go to dist fill for fill up a distribution, TI was made in the 80s. I'm limited to 8 characters, just like we were in the 80s. No spaces, no underscores. Dist fill.
Only got one.
Only got one. Oh, I didn't link to you guys yet then. We'll give it to you a break. So just be with somebody that has it right now and we'll share. I brought the cable so I can share it with you guys when we take our 5. Happily. So hit it and then hit it one more time to start it. You'll know it started when it says smallest x. Now, the reason I did this is because you have to have an idea of what this is going to look like when you're done in order to know what to put into it right now. Now, for a binomial, the smallest x is always going to be 0, because there's always that chance you're not going to get anything of what you're looking for. Always that chance. It might be very, very small, but there's always a chance of it. So go ahead and hit enter. Largest x is essentially going to be whatever n is. Let's do Mike's flock first, which would be 7. Okay. Now, I gave you 4 choices here. I'm thinking about rewriting this program because we hardly ever use uniform PDF or manual. So just pick one. You're always going to use binomial. So just hit enter again. And this is where you have to put in that independent probability that you know from the problem, which in our case was 0.9, right?
0.9.
When you go in to grab a bird, it's 0.9 girl. Remember, I'm ruined. I look at those little chicks and I see 90% girl and 10% boy. So it's 0.9. Fair enough? If you put in 0.1, what would you get? Chance of a rooster. And you get the number of, is that what you're going to ask, Anna? If you put in 0.1, you get the curve for a rooster, the number of roosters per. So that would be 0 roosters, 1 rooster, 2 roosters, 3 roosters, 4 roosters. But you've already figured out that that's going to be exactly backwards from the chickens. If the chicken curve goes like this, the rooster curve will go like this, because there's only 2 options. Maybe you didn't figure it. We can actually model that if you want to see it. Fair enough? Press enter. Let it, it's done. At this point, you can go in and look at your distribution. So if you press stat edit, you now can go in and look. L3 is from 244. I will erase that so there's no confusion. And now you can see what the likelihood of getting all the outcomes are. So, what's the chance? That's not in focus. What's the chance you got no chickens whatsoever? 0.000001. 1 in a million. No, actually 1 in 10 million, isn't it? 1 in 10 million. Should that happen? Well, it should happen 1 every 10 million trials, which means it shouldn't happen, right?
Right.
If you went to buy sexed chicks and you came home with 7 roosters, I think you have every right to go back after, well, it would take you like 6 months to figure it out, wouldn't you? It would take a while. Because they don't start showing male traits for... Oh, speaking of which, wait, hang on, time out. I'm going to run this by all the chicken keepers. Monty Cheney, who's one of the other statisticians at COCC, told me he has a almost foolproof way of identifying roosters when they're 1 day old. See if you've heard this before. Grab them by the feet. So get under their bodies, like you're going to pick up like a wine glass. Grab them by their feet, turn upside down. The girls will just hang there relaxed, and the boys apparently get pissed and like peck at your hand. And he says this is a way, even when they're sexed, to be able to ID it. So what I want to do, and I tried it at High Desert, they wouldn't let me do it. I want to grab every chicken, try it, and see if they come back 10% pecking me. Because if they come back arguably 10% pecking me, that means they're sexing at 90%, right? Because if the 10% peck me, that means I got 10% roosters, if this is actually true. But if none of them peck me, I'm like, well, I know there's some roosters in here. Or they're sexing at 100%. You see what I'm saying? It raises an even cooler question. If I could just find a store that'll let me do it. So anyway, think about it. Next time you buy like 30-day-olds, grab them by the feet, turn them upside down, and see if they peck you or not. And then let me know. Maybe you can mark them with like a Sharpie or something and follow them as they grow up and see if they turn into boys. I don't know. I got no data. I got a hypothesis and no data. That drives me nuts as a statistician. I want to test the damn thing. Sorry, back to this. So, almost no chance you're going to get all boys. Almost no chance you're going to get 1 girl and 6 boys. I mean, that's almost as small as that. It's slightly larger by 0.9, or by 9, I guess, 9 times larger. And these are all pretty small. Is this scientific? Is that pissing you guys off at all?
No, maybe.
It should. It's 10 to the -7th. And I think if you, let me see, if you go here, yeah, eventually, no, that's no good. No, it's always scientific notation. Eventually it'll show you decimals. So this is just very small, very zero, less 0. Okay, now we're starting to get into stuff that doesn't look like scientific notation, but it's still pretty small. That's 0.3%, which means if Mike was to buy 1,000 flocks of size 7, it's a lot of birds, right? 1,000 flocks of size 7, 3 of those 1,000 flocks should have 3 girls and 4 boys in it. That's pretty rare, isn't it? That's one of those, if you think about it, that's one of those random clumps, right, that we were talking about. That's one of those random clumps. If you, and Eric, nodding back to what you said earlier, that's like envisioning them as 7 bird cycles blocked out. In one of those 7 blocks, you're going to have 3 and 4. It's because of that clumping. It's going to happen in a small, but you never know when it's going to happen. 3 in 1,000 is the rate at which it happens. Cool, and now we're starting to get into some numbers. There's 2.3%, still pretty low, but now I'm starting to get nervous, right? 12.4%. That means 1 out of 8. This, to me, this is my personal opinion. This right here is the dividing line between when I start getting nervous about having roosters. When these probabilities leap from here to here. This is all of a sudden like, I'll see this in a lifetime, maybe. I'll definitely see that in a lifetime, won't I? 37.2%? That's roughly 1 every 3 times you buy a flock of 7 birds, one of them's going to have a rooster in it, which makes perfect sense. If we're operating at 90% efficiency, that means every 10 birds is going to have 1 rooster on average. You now have bought 21 birds. If you've bought 3 flocks, you should have some boys in there. Hopefully that makes sense. Good. And here's the part that drove Mike nuts at first. Keep going down. That's the chance he gets all girls. Notice what it's less than. It's less than 50%, which means it's worse than a coin flip. Mine was pretty low, right? With 4, it was 2/3, but that's above 50%, right? But his is below 50%, which means there's a better chance he's got a boy mixed in somewhere than he doesn't. With me, with 4 birds, there's a better chance I have all girls than 1 boy. With him, there's actually a better chance that he's got a boy than doesn't have boys. And once he saw this, he's like, okay, I feel better about it now. And I said, you didn't get the modal probability, but if you look at it from the chance of at least 1 being a boy, statistics 1. I mean, honestly, statistics 1. Is that fair? You guys buy that? Dave?
So the L2 column is the chance of there being at least 1 boy in the amount of...
Careful. Each element in the L2 column is the chance of that many girls, and therefore that from 7 many boys. So this is the chance of 3 girls and 4 boys. This is the chance of 4 girls and 3 boys. This is the chance of 5 girls and 2 boys. This is the chance of 7 girls and no boys. Fair? The at least, Dave, the at least is all these added together and not that. That's why I mentioned Project 2 and Project 1 earlier, because we still use those ideas in this as well. Is that fair? Thank you, sir. Now, if you want, I gave you another program. I gotta turn something off real quick. I gotta turn all this off from before. If you go back to program, there's something called dist draw. If I linked up your programs, I gave you this one too. If you press that, it'll actually give you a graph of that distribution. So it gives you an idea of scale. And the reason I like this one is, you can visualize in 2D versus 1D that jump in probability from what I'm not worried about to, oh, now I'm worried. You see what I'm getting at, friends? So this gives you a visual. You might never use this. It's totally fine. If you do the Palin quiz, you're probably going to want to use this, honestly. But you might never use it after you leave this class, and that's totally fine. But I like having the visual, too. It's a highly skewed distribution, right? It's a highly skewed distribution. Very, very highly skewed. So I wouldn't trust the standard deviation too much. The average is okay. Even though it's skewed, it's a population, which means the sample won't be confounded by outliers. So that means we don't have to worry about outliers because we have the entire population. So you could totally take an average of this happily. Fair enough? So if use it in good health if you want to. Now, Sandra, your friend's flock.
Yeah.
Everybody, program, disfill, run it. Sandra's friend bought 20 birds. I want to analyze how many girls we can expect in a flock of 20, yes?
Okay.
Smallest number of girls? Still 0. Largest number of girls? 20. Ostensibly, we want that if we want eggs, right? Okay. It's done now. Fill it with binomial. Still 0.9, because we're assuming you're buying 20 birds from a large distributor. that's operating at 0.9. Takes a little bit longer for it to fill now because it has a few more cells to fill in. Cool. Now go look. And you can look either way. I'm going to go into the distribution first. Look at those scientific notation values now. Hopefully they make sense. 1e negative 20 is 10 to the negative 20th power. But hopefully that makes sense. 0.1 is 10 to the negative first. So each time you multiply by 0.1, you get one more negative exponent tacked on. 20 birds, 20 negative ones. Should you get 20 roosters? My God, no. You also shouldn't get 19 and 1 or 18 and 2. These are all very unlikely, yes?
Yeah.
Very unlikely. When does it stop becoming unlikely? Okay, there's 0.2%. There's almost 1%. That's 3.2%. Now I'm starting to get twitchy. Okay, there's 9%. Oh God, that's 1 in 11. That's 1 in 11. Oh, sweet Jesus. Okay, there's 1 in 5. How am I getting these numbers? 1 in 5. What the hell am I doing? Is this magic math? Is this just magic math? No. How am I calling that 1 in 5? Why am I calling that 1 in 5?
Because it's 20.
Because it's almost 20%. Thank you, guys. I'm rounding these things off. 0.9 is one of those ones I remember. 1/9 is essentially 11 and things like that. So here we go. 28%. That's 2/7. Sweet Jesus. And now look. Look what just happened.
What happened?
What happened? Look.
It jumped to 2.
Explain, please. What the hell? Linda, please explain.
Well, the bigger your flock, the more chance you'll have a boy. So
Remember. Yeah, say that again. That's not.
what I just said.
What you just said is perfect.
When you get a large flock, you will have a higher chance of having a boy.
Every 10 birds you buy, what's in that 10 birds? 1 boy and 9 girls on average. You just bought 2 sets of 10, which means the most likely outcome should be 2 boys, 18 girls. Huh. And it says it to you right there, doesn't it? That should be the most likely outcome. It's actually rarer now. Remember what happened with Mike? It was still the most likely outcome. It's because he hadn't bought 10 birds yet. As soon as you buy 10, it starts tipping down. Because probability statistics says every 10 you're going to have a boy and 9 girls. That's what 0.9 means, right? Over time, on average, looking at a snip of a larger run. Fair? Is that okay? You guys buying that? Very nice analysis, Linda. So you see all of these. You got, again, there's this line in the sand right there. You've got the things you don't have to worry about so much here. But then remember that all of these have at least 1 boy in them. So then you have to start saying, okay. Now, your flock, they had how many boys?
8.
8 boys. Now, 8 boys. So this is 1 boy, 2 boys, 3 boys, 4 boys, 5 boys, 6 boys, 7 boys, 8 boys. Goofy outlier. Goofy outlier. Or maybe
Bad sexing.
bad sexing. See, there's 2 explanations for that, right? Either an outlier. Of course it can happen, right? We actually breezed right by it, didn't we, guys? We breezed right. You said 8 boys, right? So that's 12 girls.
12 girls.
There's a chance. That's pretty small. That's pretty small. So either we got that goofy outlier, or they weren't sexed at the correct 90%. They were sexed poorly. Maybe that's exactly what we should have gotten, given the sexing if they were sexed a different way. Maybe they're only operating at 80% or 70%. Could you check that distribution in here?
Yeah.
Of course you could. Just put 0.8, 0.7, whatever else you want to put. You could actually go retrofit a distribution to fit that outcome, assuming that outcome wasn't an outlier. This is what we do in 244 all the time, FYI. It's part of 244 is trying to find that. It's called a posterior distribution. Super fun. Not like posterior like your butt, but like posterior like here's data, what could it have come from? We thought it was over here, but it actually looks like it's more like it's over here. What should that look like? So, kind of fun stuff. Fair? Making sense? Can you run 1 var stats on this distribution once you have it? Of course you can. Go do it. That's kind of why I set it up the way I did, because I wanted you to be able to. Just make sure you do L1, L2, because it's a weighted average, right? Now, again, I would ignore the standard deviation. It doesn't mean a whole lot. This is still a pretty skewed distribution. fairly skewed. It's leaning way to one side. Let it go. The average, though, I mean, you're going to average 18 girls out of 20. You knew that, though, because of what Linda just said. You bought 20 birds. There's a 90% chance of a girl. 0.9 times 20 is 18. You've already figured out one of the coolest parts of the binomial, which is the little formula. You don't need one of our stats to get the average of a binomial. You could do the average without even having the distribution, which is totally badass about the binomial. It's one of my favorite parts about it. We'll get back to that. We'll come back to that. But Gail, let's do your flock and then take 5, yes? Okay, now don't tell me how many roosters you had. You told me last week, but I forgot.
Well, I told you I bought 10, and then I had 4 roosters.
Ah.
And then, but right now my flock's at 30.
Okay, but you... So you're not sure if those 4 came from the flock of 10 or you did?
No, they're separate.
But, okay, so you bought a flock, you had 10, and there were 4 roosters in that?
Yeah.
That sounds strange to me.
Yeah.
That sounds strange to me. Let's build that flock first. And then we'll build your next flock, putting them all together.
Okay.
Okay? So, sorry, I get excited about chickens. Let's 0 to 10. This is Gail's first flock. How many girls would you expect?
1.
9. 1 rooster, you got it. 1 rooster, 9 girls. The question is, how unusual is 7 girls, or excuse me, 6 girls, 4 boys. So binomial, 0.9. Again, here she comes. I'm going to do the disc draw first. There it is. Okay, there's your predictable little boop. Because the average, as you guys already figured out, is 9.
Yeah.
Right? The average is 9. This is all girls. So although the chance is still good, it's not as good as 1 boy. Gail, where are you? 1, 2, 3, here. There's your flock right there. That looks pretty unusual because that would even fall under my line of that's what I think. Anything above that is expected. Anything below that is unusual. So now if you need more precision than that, you can also press trace on this and trace over to it if you want. There. Oh no, that's not you. You are here. Yes, 1% chance of happening. Congratulations, sister. Don't play the lottery anymore. You used up all your luck here. I love making that statement. It's so asinine. But that's the idea is, that shouldn't have happened, huh?
No.
That shouldn't have happened. But outliers happen. They just don't happen very often. And it sounds like you buy chickens a lot, yes?
Yeah.
So now you've got a flock of 30.
Yeah.
How many boys do you have or do you not know yet right now?
Well, I have.
At least 4.
No, they got.
They're gone. But they were there though.
Yeah.
So let's just forget those, and let's look at your 20, which is the same as your friends that gave you the 20 originally. And what do you think? How many boys you got?
Probably like. I'd say what 3.
3, which if you remember is well within the realm of what we should have gotten out of 20. Remember that?
Right.
Remember the Sandra Lloyd's friends population? 2 boys out of 20 is the expected number. 3's not that far off. It was a hiccup down, but it wasn't that. It was still very likely to get that result. So there we go.
Well, buying 10 and getting 4 was kind of.
Yes, and this is what I wonder. I wonder. So you've heard the 0.9 too. I'm assuming, right? The 90% chance sexing. So even before knowing that, getting 4 boys and that's too close to a coin flip to me. What that almost sounds like to me, if you don't mind. It sounds like to me, you bought 10 birds, but they sexed them without sexing them. Which means, this is what the curve should have looked like. This one right here, yes? Because now, you're here. You're here, which makes a lot more sense. You're higher up, way above my level of, this is not what I'm expecting, this is what I'm expecting. But of course, they're not going to tell you that if that actually happened. And it probably didn't happen. You just were fortunate enough or unfortunate enough to get that one goofy little outlier occurrence. Please.
I wanted to ask her, did she let her kids pick them out?
No.
No?
There's a cool statistical question.
Because see, I always wondered if, like you were saying, that the roosters are more spunky, that when you look
Well, you hold them upside down.
Well, yeah, when you hold them upside down, but when you're looking at them
Maybe
in the
even
den,
then, huh?
Then the kids, like your son, I mean, they're looking at him and like, oh, this one's
He's ADD as I am.
Yeah. 'cause
Shiny squirrel. Shiny squirrel. No, totally.
the one's more active, the males, than the hens. Yeah.
A related question.
Yeah.
A related question. See, this, I thought the same thing. The acting differently. It's the whole, you guys know now that certain pop machines stay dormant until you walk by them. And then the lights come on and they go,
Yeah.
That's genius for 2 reasons. Number 1, because it saves power.
100%.
Number 2, it gets your freaking attention when you walk by. right? Have you ever noticed that? There's one in the basement of Pioneer's, the first one. I used to walk by it every morning to go take my shower at Mazam. I walk out the basement door of Pioneer. I'm like, holy shit, there's that machine again. Same thing with the chickens, right? Maybe the roosters are doing something different as that day old. I don't know how you test that because there's so much chaos in those bins.
There is, but something's drawing them.
Maybe on average there is a little, and even if it's only a 5% twist over a long enough period of time, that might be meaningful.
Mm-hmm.
Something else to think about, we bought four more day olds this year. So viewing it in Eric's way, that's 2 4s that became 8. So theoretically speaking, I should now be getting a rooster with pretty good likelihood. Right, with pretty good likelihood. I'm past Mike Smith's flock. He had 7, I had 8, which means I got about a 40% chance of getting all girls. I'll never know though, because Mary killed Fern or May, and I forget which one she killed. She killed one of the new girls, but she killed her before I knew whether she was a her or not. Maybe he was showing male dominant traits, and she took him out because she was the alpha female. But he was still small enough to, I mean, maybe, it's possible, right?
Yeah.
So that could have been my 1 in 8, which would have been a perfectly likely explanation for how many roosters I should have had, but I'll never know because not only did she kill them before I got a chance to test them, some raccoon drug her away the next day. So I try to bury things in my backyard and the raccoons always get to them. But anyway, so yeah, something to think about. David.
I was just wondering what you said that they're sexing them wrong, because you're saying that you don't know what gender they are until like weeks after they're born.
Well,
So
months
are
after
you
they're
saying
born, I
that,
think.
So you're saying that the people who like distribute them know?
Yes, they have some method of sexing a day-old chick.
On dirty jobs.
It's on Dirty Jobs.
Oh, it's